Number 24 uses Dalton's law of partial pressure to find the total pressure, and then the mole fraction equation to find the mole fraction of each of the gas. So that's the two things we need to do. We have helium, argon, and xenon all together. We know their partial pressures, and we need to find the total pressure, which we'll find by adding them all up, and then we need to find the mole fraction of each of these elements in the mixture. So first things first, pressure total is going to equal the sum. Pressure HE plus the pressure from AR plus the pressure from xenon. So that means all I have to do is add together 0.467 plus 0.317 plus 0.277, and that all equals 1.061 atmospheres. So that's my total pressure. That's one of the things I needed to find. What's my total pressure? The next thing I need to find is what's the mole fraction? Well, we had an equation, and it tells us that the pressure of any gas in a mix is equal to the total pressure times the mole fraction of that gas, which means that the mole fraction of any gas in a mixture is equal to the partial pressure of that gas divided by the total pressure. All I did was divide both sides by total pressure. Well, I know the total pressure now. I know the partial pressures for each one. So one after another, I'm going to say that the mole fraction of HE is equal to 0.467 divided by 1.061, and the mole fraction of HE is 0.440. The mole fraction of argon will be equal to the partial pressure, 0.317 divided by 1.061, and that'll give me 0.299. Notice I'm not putting any units on mole fractions. There are no units. It's just a fraction. The last one, the mole fraction of xenon, will equal 0.277 divided by 1.061, and the mole fraction of xenon is 0.261. So there's my 4 answers for this problem: total pressure and mole fraction for each one.